You are welcome to my channel. I'm so happy to meet you today. Okay, today we'll be looking at for the mathematics questions. So I would like you to get your pen and paper because we are doing these together today. Okay, so let's go. My first question is on polynomial, and I have my polynomial f of x to be 2x cubed plus px squared plus qx minus 5, and it has x minus 1 as a factor. X minus 1 being a factor means that if we divide the polynomial by x minus 1, we'll have no remainder. Okay, we have 0 remainder. And a remainder of 27 when divided by x plus 2. So if we divide by x plus 2, we'll have a remainder of 27. P and Q are constants, and we are to find the value of these two constants, P and Q. So let's do this together. So I'll start by putting down what is given, and then start with the factor x minus 1. And I'll equate it to 0. Okay, this is to never make the value of x, and that gives us x to be equal to 1. So I'm going to put the value 1 for x in that polynomial, and I will have this. Okay, f of 1 now is 2 plus p plus q minus 5. Then remember, x minus 1 is a factor, so it means we are going to equate it to 0. Okay, so I will then go further to simplify, and I will have p plus q to be 3. Okay, so let's call this equation number 1. Okay, let's call it equation 1. Then remember that we have x plus 2. Okay, which we are told that if we divide the function by x plus 2, we'll have a remainder of 27. So let's also equate this to 0 so that we'll get the value of x here, and that gives us x to be minus 2. I'll also put that same value for x in this polynomial, and this is what I have. Remember, it's equal to 27 because that is the remainder if we divide the polynomial by x plus 2. Okay, so I will simplify further, and I will have 2p minus 2q to be equal to 48, and then I will divide through by 2, that is 4p over 2 minus 2q over 2 equals 48 over 2, and this will give us 2p minus q to be equal to 24. So let me call this equation number 2. Okay, so I will add equation 1 and 2. So in doing that, I will have this. Okay, this is my equation 1p plus q plus 2p minus q. I'm adding the 2, and that will give me 24 plus 3. So this is, I'll have this, and this giving me 0. Then I'll have 3p to be equal to 27. So that is it. So I have 3p equals 27 divided through by 3, and that gives me p to be 9. So all I need to do is to put p equals 9 in equation 1. So if I do that, I will have this. Okay, so let's do it now somewhere here. This implies that p plus q, which is 3, becomes 9 plus q, which is 3, and that makes q to be 3 minus 9, and that is minus 6, okay? So that is minus 6. So that is why we are having this minuses. So RP is 9, and sorry, is 9. So let me clean it out. So Q is 9, not so Q. Right? So RP is 9, and RQ is minus 6. So that is it for this polynomial. You can try it again and again and again. And if you have any question, drop your question and it will be attended to. Okay, let's go to the next question, our question number 2. Okay. So here in our question number 2, we have to evaluate definite integral. Okay, and this is how it's done. So we start by looking at root x. Okay, I wanted to give it another variable. So I say let root x be u. Okay, and if I take the square of both, I will have x to be u square. Okay, and then if I take derivative of x with respect to u, I will have the x to be 2u du. Okay, so now let's substitute u in place of x in the given integral. So we'll have this. So our x now is u squared. Okay, and our root x is u. The x is now 2u du. Okay, so this can cancel out. This cancel out, and then I will multiply. Let me do this here. Okay, so 2, I will now have 2u squared, then 2u squared minus 3 du. Okay, this is the same as having, okay, 4 u raised to the power 4 minus 6 u squared. Okay, du. All right. So with this now, I can take the integral, and this is what I have. Okay, now substitute the values given. So have 9 and then 1. Okay, do your normal arithmetic, and then you have your final answer to be 141 whole number 3 over 5. So that is it for this integral. Alright, we'll go to question number 3. Alright, so this is what we have in our question number 3, and this is first bracket we have p plus 1 over 2 root 3. Second bracket we have 1 minus root 3 all squared. These are equal. If I take the product, is equal to 3 minus root 3. So we have to find p, which is a constant, and this is the solution. Okay, this is what is given. The first thing I would do is to expand this. Okay, to expand this. So doing that, I have to multiply this by itself. That is what I did here. 1 minus root 3 times 1 minus root 3. And this is what we have. Simplifying further, we have 4 minus 2 root 3. Okay. Then I will now substitute in place of 1 minus root 3 all squared 4 minus 2 root 3. Okay, so now I can now multiply these two brackets, this, okay, this and this. So in multiplying, I have this. Okay, collect like terms. This is 4p minus 2p root 3 equals 3 plus 3 minus root 3 minus 2 root 3. Okay, so we take the factor. The factor here is 2p. Okay, and then we also take the factor on the side. So we have this. Alright, so we are having 2p brackets open 2 minus root 3 equals 3 roots minus 2 minus root 3. Sorry. So this will cancel. So I have 2p to be equal to 3. And that gives us p to be 3 over 2, which is 1.5 or 1.5. Okay. So move further to number 4 question. Alright, we have combination. And this is it. So apply the format. And this is what we have. So I need to work on the numerator so that I can get it in this form. Okay, so we have, so with that now I can cancel this and this. Okay, and then I'll have this. Simplify it. 5y, open the bracket, 5y minus 1 all over 2. Okay, plus 190. By cross multiply, I'll have 5y minus 1 equals 380. Okay, so with that now, good. So let's divide by 5. Let's divide by 5. Okay, divide this by 5 and also divide this by 5. So that gives us y bracket open 5y minus 1 to be 76. Okay, so we can open the bracket now and we have 5y squared minus y minus 76 equals 0. So we're having a quadratic equation now. So this is a quadratic equation. Alright, so we factorize. It's factorizable. We factorize and then we have this. Okay, you should know how to factorize. If you don't, I have a video on factorization. You can go through it. And then we now have this. So it's either y minus 4 is equal to 0 or 5y plus 19 is equal to 0. And that gives us y to be, okay, that means our y is 4 or minus 19 over 5. Okay, which you can simplify further, okay? So that will give us 3 whole minus 3 whole number 4 over 5. Okay, alright, so go to the next question. Question number 5. Now in this question number 5, we have a table that shows the distribution of monthly income in thousands of naira of workers in a factory. Okay, so we have it there. The problem is we should draw a histogram for this distribution and then use the histogram to find the mode of the distribution. So let's start by putting the necessary things we need to have in the table. We need the class size, we need the class boundary. So here I have it. Okay, so this is our class interval. This is our class interval. Now you observe that we have unequal class interval. Unequal class interval. Okay. Why do we have, and because we have unequal class interval, the frequency table we're going to have is frequency density table. Okay. So starting with class boundary, the first boundary we have is 134.5 and to 139.5. So how do we get the boundaries? For this, you will subtract 0.5 in the lower limit and add 0.5 in the upper limit. Just continue that way, okay? So that's how you get your boundary. Alright. Subtract 0.5 in the lower limit and add 0.5 to the upper limit. So continue that way and you're done with the boundaries. Okay, the frequency remains the same. These are the boundaries now. Now for us to get the class size, for this one is the upper bound, which is 139.5 minus the lower bound, which is 134.5. Okay, this one is 149.5 minus 139.5. Keep doing the same to get the bound. Now the bound helps us to know the size, and that is how we discover that we have unequal class interval here. So we have some 5, some 10, 5, 10, 5. Okay. Now this is the frequency density, which is the frequency over the class size. Okay, which here we have 20 over 5. Here we have 42 over 10. Here we have 28 over 5. Here we have 38 over 10. Here we have 22 over 5. Okay. So now we have our class size, our class boundary, and our frequency density. And I say why we are using frequency density is because we have unequal class interval. So let's plot our histogram now. So here is my graph. So vertical line represents the frequency density, and then the horizontal is for the class boundaries. So I'll start with the lower class bound, which is 134.5, and go on to 174.5. Okay. Now I'll fix the bounds. I have it already there, so let's put the bars. And for histogram, the bars are connected. So my first bar, good. So that is 4. Okay, next is 4.2, and on and on and on and on. You can see. Okay, these ones are the ones that have this is 5, this is 10, this is 5. There's a class size here is 5. Class size here is 5. This is class size 10, and so you can see that the class size are also maintained in the bars. Okay. Now for us to take the estimated mode for the distribution, we'll look at for the bar with the highest height. So the bar with the highest height is this bar. Okay, from the boundary 149.5 to 154.5. Okay, so that's the bar with the highest height. So there I will now join the vertex of that bar to the one in the left and then to the one in the right. And then where the two lines intersect, I will now draw it to the boundary. Okay, so you can see where I have it in the boundary. Alright, so that is where the mode is. So the mode is 152.5. So that is the mode of the distribution. Okay, alright, so we'll move over to the next question. Next question, question number 6, is on probability. So we are told that a bag contains 24 mangoes, okay, out of which we have 6 bad mangoes. Okay, if 6 mangoes are selected randomly from the bag without replacement, we have to find a probability that not more than 3 are bad. Not more than 3 are bad. So here is how we solve this. Okay, let's find the probability of the bad mangoes, and I call it P, and that is 6 out of 24, and that is 1/4. So let's also find the probability of the good mangoes. I call that Q, and that is 1 minus the probability of the bad mangoes, which is 1 minus 1/4, and that gives us 3/4. Okay, now I work this out. Remember, we are looking at a probability where we don't have more than 3 bad mangoes. Okay, so our x is less than or equal to 3. So it's either we have a 0, no, that is no bad mango, or we have just 1 bad mango, or we have 2 bad mangoes, or we have just 3 bad mangoes. And that is this. Okay, so with this now we calculate. Okay, since the denominators are the same, we just add the numerators and always reduce to the lowest term, and I have fraction decimal here 0.9624. So the probability that not more than 3 mangoes are bad is 0.9624. Okay, if you have questions, drop it in the comment box below. So move to the next question, question number 7. Okay, here we are looking at the speed of a moving bus reduced from 45 meters per second to 5 meters per second with a uniform retardation of 10 meters per square second. Okay, we are to calculate the distance covered. So I'm using this. Okay, here are the given parameters. I have the initial velocity to be 45 meters per second, and then the final velocity to be 5 meters per second. Then I have retardation, which is a negative of acceleration, and that is minus 10 meters per square second. Okay, so, or second square. So I'm going to use this equation of motion, v square equals u square plus 2as. Okay, as is our distance covered. Okay, so substitute the values and then we'll work out what we have. And okay, so when we divide, we have our distance covered to be 100 meters. Okay, so that is the answer for 7A. We have a 7B Okay, so here is a 7b. We have a bucket full of water with mass 16 kilogram, pulled out of a well with a light inextinguishable rope, okay? And its acceleration when the tension in the rope is. We have to find its acceleration when the tension in the rope is 240 newtons, okay? And the acceleration due to gravity is given as 10 meters per second square. All right, so let's work this out. So we know the weight of the water is mass times acceleration due to gravity, and the mass given is 16 times 10. Acceleration due to gravity gives us 160 Newton. Okay, so move further to that. Tension is 240 Newton. So we'll work on the resultant force, which is tension minus weight of the water, and that gives us 18 Newton. And then with that we can find the force, which is okay, we already know the force. Resultant force is given, and then it's mass times acceleration. So the mass we know is 16. Okay, acceleration is what we are looking for, and we know the force, the resultant force is 80. So if we divide through by 16, that gives us 5 meters per second square, and that is the acceleration when the tension in the rope is 240 newtons. Okay, all right, so go to number 8. We have vector x given as minus 4, 3, and vector y minus 9, minus 15. We are to calculate to the nearest degree the angle between the vectors. So let's do this together. So first thing I'll do is to take the dot product of the vectors. Okay, so the dot product of the vectors, and I have 36 minus 45, and that gives me minus 9. Okay, now I'll take the module of both too. Okay, if I take the module of both, I have the module of x to be 5 and the module of y to be root 306. Now here is the cos of the angle. Cos theta is the product over the module of both. Okay, the product of the modules. Okay, and if I substitute the values I have, so I have cos theta to be minus 0.1029. So if I take the cos inverse of that, I'll get the angle itself, and that angle is 95.91, okay, degrees. And remember, we are taking to the nearest, so to the nearest it gives us 96, and that is your final answer. So thanks for listening, and God bless you. If you have any question, drop it in the comment box below. Thank you.